So introduction. I have been doing body scanning for over 7 years. I started a company called PersonalFashion, and I specialize in 3D body scans for apparel and costume industries, and I make custom dress forms from those scans. Usually, I take 3-4 scans of each person, and then I obsessively analyze and compare them to know which scan I'm going to use for making a dress form. I use a handheld scanner, Artec EVA Lite, to establish the accuracy of the scanner itself and the process. I took 4 scans of the same dress form. I also took the 3 scans of the same person with different positions of the arms. So in general, the distance between the 2 surfaces is within 0.3 millimeters. Pretty reasonable accuracy, a little bit of an overkill, maybe even for a human body that moves, that breathes. Here are the examples of the scans that I took of the person. So, after the general 3D model was obtained, I clear out the underarm area. And also, I smoothed out the top garments. And on the corner there, the black and white image, you can see how basically easy it is to remove some straps from undergarments if they're relatively small. How the body changes with the different positions of the arms is, well, of course, underarms, the shape of the shoulder, the shifts in the chest and the back curve, the balance of the front and back, that's something very important for pattern making, and how the armhole would need to be placed differently, the asymmetry changes, and of course, the person tends to move during the scan. The arms moving between the relaxed position about 10 degrees and A stance, kind of a relaxed A stance of 35 degrees. When you shift between the 2 images, you can actually see the chest going a little bit up, the arms and the shoulders go a little bit towards the back. But why the A stance and the T stance are widely used in 3D scanning? Well, because we want to know what's going on with underarm. We want to see the separation between the underarm and the body. A lot of people, even at 60 degrees, you still don't have that separation. But at the same time, we want the shape of the shoulder that is at relaxed position. So we can see also how the shoulder goes forward. The blue line goes a little bit more round towards the front rather than the yellow line. So the yellow, that's the arms down, and the blue is the T-stance. And the view from the top, we can see how the arms go towards the back and how it changes the shape of the back curve. And that's going to affect our measurements. So if the arms go more towards the back, that makes the across back measurements shorter and the across chest larger. As the chest rises, it changes the position of the apex. And you can see that the apex shifts from the lower arm position, about 10 millimeters, and the full T-stance, that's about 15 millimeters. Because we are measuring higher in the back, where the back becomes wider, we are reading a very different measurement. So in both cases, we are measuring the bust, but actually we are measuring different part of the back, depending if we are measuring in the relaxed arm or A stance. And it's quite common to see asymmetry increasing as the person raising the arms, or the movements during the scanning. That makes a gigantic difference. With the relaxed arms, you can do the scan most of the time with not so many problems, versus with the T-stance, you arrive to that type of raw data. So now that we saw the differences, does it actually matter when we are making garments? So I would say yes, or at least it has to be considered for any application that is high stakes and you're really going custom. You're really going to make something that's going to fit that person. Of course, it's just the case study, represents one person. Everybody is different. We're going to have a lot of different variations and more research needed, especially for different body types. People very athletic with a lot of muscles, and people with a higher body mass index, and older people. They might not even be able to lift the arms higher than 30, 40 degrees. That's